Hello and welcome to another physics program. And I'm going to do 2 or 3 programs all about one of the most important things that happens in the universe, and they're called waves. And the Kujuluyang dance group have come along to help me explain to you what waves are. You learned about waves in class 9 and class 10. You have to know about waves for your examination syllabuses. So let's see if we can look at how useful and important waves are and see exactly what is a wave. Well, we can hear Kujuluyang dance group. We hear them because of sound waves. We can see them because of light waves. Waves are responsible for 2 of our most important senses, our sight and our sound, our hearing. Without waves, communication would be very difficult. So let's go and see Kujuluyang dancers and ask them to help explain waves to us. Thank you very much for being here this morning. And if I can interrupt your dancing and singing and ask you all to help me to explain waves to all the school students in Bhutan. One remarkable thing about waves is that they are a way of sending energy from one place to another. And they send energy from one place to another in a very, very unusual way. I'm going to make her move. I'm going to send some energy to her. I can do it in a number of ways. The first way is if I myself walk over to her and, with great respect, shake her. So I had to move here to transmit the energy to Chode. But there's another way of doing it, which means I don't have to move. Here's a stone, and I'm going to throw it at Chode, and it will make her move. You notice I don't move there, but I send a piece of matter, a piece of material, a stone over there, and it makes her move. Are you ready, Chode? Yes. She moved. I didn't move. The stone moved through the air, and it caused her to move. Material had to go from me to her. But there's another way of making her move as well, which means I don't need to move. I stay here. I don't have to throw anything at her. I simply go, Chode, move. And there we are. So the first way, I had to move over there to give her energy. The second way, I had to throw something at her to give her energy. The third way, I used sound waves. Sound waves. So the first thing is, a wave is a way of transmitting energy from me to Chode, standing there. Now, let's just look at my friends from Kujuluyang. You're all lined up, ready to help with waves. I'm going to give some energy to this chappie here. I'm going to shake him, and he gets movement energy. I'm going to send that energy all the way down the line to this person here. Now, the first person could have done what I've done, which was walk along and go shake like that. But we're going to do it using a wave. So, first of all, I want you all to link arms. Ready? Now, you must keep your arms linked together, tightly. Now, I want you to watch what happens. They don't know what I'm going to do. So let's see what happens. Are we ready? Keep your arms linked. Are you ready? Now, if you look what happened, and we'll do that again, the energy from here traveled down to this person in the end who moved. Let's do that again. Watch what happens. Arms tightly linked together, not loose, tight. You're too loose. Are you ready? Now, I wonder if you could see what happened there. The movement that I gave to this person was transmitted to the next, then to the next, then to the next. Please notice, they didn't all move forwards together. What I mean by that is, watch here. Now, when I say now, I want you to all move forward and backwards together. And back, and forwards, and back, all together. That is not a wave. And I want you to look what they're doing now and what they're going to do in a minute. Now isn't a wave. They're all moving at the same time. Now we're going to make them move in a wave. Watch the difference. I hope you notice the difference. In a wave, this person moved first, and then the next, and then the next, and then the next, and then the next. The movement traveled down the line. You could see a sort of wave traveling that way, but what was actually moving that way? What was moving that way was energy. Energy from here to the person at the end. Notice, no dancer moved that way, only energy moved that way. What did the dancers do? The dancers moved this way, backwards and forwards. Notice, backwards and forwards of the dancer, energy going that way. Backwards and forwards of the dancer, energy going that way. If you can imagine, this is almost a T. Movement, energy, T. Transverse waves. That's one sort of wave. Is a transverse wave where the movement of the individual particles is like that, but the energy transfer is like that. And if you need to remember the word transverse begins with T, and the movement and energy form like a T. If you can imagine my arm sticking out backwards there, and this one, that one, you've got a T shape. Transverse waves. Movement of the particle is like this. The energy is transferred like that. Transverse waves. Examples of transverse waves are waves in a rope. So let's get our friends here to do a transverse wave again. They're holding a rope. Think about what the rope looks like. Stop. Now, I want you to look at the pattern. especially if you can see from above, we've got a wave shape there. Now, I want you all to put the rope down at your feet on the ground. Exactly where your feet are. We've got a wave shape in the rope. The rope's going like that. How did that happen? It happened because each dancer was moving forwards and backwards. Right, so we tried to look at the wave in a rope with the Kuje Luyang dancers, but unfortunately the rope didn't really show up very well against the ground. So what we've done is bring the rope up here to BBS and try to show waves in the rope again. Now, Norbu at the end there is going to make a wave. And just to show that no particle of the rope is moving that way, I'm going to tie my beautiful clean handkerchief around one bit of the rope, and when Norbu makes the wave, you notice all that happens is it goes like that. Now remember T, transverse waves. The movement of the rope is like this, but the movement of the wave is like that. And if you think about it, it forms a letter T for transverse waves. Now, let's have some more waves. And we can see the transverse wave in the rope. Now, I'm going to go down here to Norbu, who's making the wave. And if I could just take this, Norbu, for a moment. We remember we have to know about the frequency of a wave. Well, that's how quickly Norbu moves his hand here. Norbu, will you make us a low frequency wave? And now make us a high frequency wave. Quicker, quicker. So that's frequency. Low frequency, high frequency. Okay, so Norbu, will you make us a low amplitude wave? And now give us a big amplitude wave. And that tells us how far the vibrations of the rope are going to go. Low amplitude, they only move a little bit. Big amplitude, they move much more. So frequency and amplitude we can see. We made the transverse wave like this, horizontally. I can also make it like this, vertically. It's still a transverse wave, and so it's still fulfilling the requirement of a letter T. I'm moving this way, the wave is moving that way. And the interesting thing is, you may have heard of Polaroid sunglasses. Well, we'll talk about this more in a future program when we talk about light waves, but light waves are transverse waves. And light waves come like this, or like that. And if you wear a pair of Polaroid sunglasses, the Polaroid cuts out all the light waves which are like that and only leaves the ones like that. So we'll talk about that in a future program. I'm now going to make the dancers jump up and down, and they'll make a wave that looks like this.
Okay, that's it. That's it.
Notice how what we saw there was just like the wave in the rope. They just did a transverse wave, but you'll notice The movement of each person was like that, but the energy transmitted from there to here like that. Movement of the particles, transmission of the energy forms a T, transverse waves. Easy to remember. Examples of transverse waves: waves in water that we'll look at a little later, waves in the ocean, earthquake waves, light waves. They're all examples of transverse waves. Very important. And now we're going to see if the dancers can demonstrate a second type of wave called a longitudinal wave. This is how sound waves are transmitted. A longitudinal wave. Now you notice how I said a longitudinal wave. You actually spell it a longitudinal wave. But if you remember a long, it helps you remember that in a longitudinal wave, the vibration is along the same line as the energy. Let's see if the dancers can do this one. Right. A longitudinal wave is when the vibration of the person is along the same direction as the energy transfer. The energy is transferring that way from me to the person at the end. But each person is moving like that. It's a sort of a compression wave. Quite different from the transverse wave. Are you ready? I'm not going to tell them when I'm going to do it, so it'll be a bit of a surprise. You notice in that case, I repeat, the movement of each person was supposed to be that way, but the energy transmitted in that direction. The movement of the particles is along the same direction as the transfer of energy, a longitudinal wave. This is how a sound wave works. If you imagine each one of these people is a little particle of air, when I go, I cause the particles of air to move, and the movement of the particles of air transmits right down to the end. Just like the sound comes out of my mouth, vibrates the particles of air, and the energy goes to the person I'm talking to. Sound is a longitudinal wave. With Kujie Liang, we also looked at longitudinal waves. And you remember everybody moved like that and some people fell over. Well, the thing is with a rope, I can't show you a longitudinal wave because if I try to vibrate the rope like that, the rope just folds up. So I'm going to have to show you a longitudinal wave on the computer. Here I've got a picture of waves, and I'm going to enlarge it to fill the whole screen. And the wonderful thing about things I can download from the internet, they can be movement, animation as well. So, first of all, we're going to make a transverse wave in this coiled spring, and also a longitudinal wave in this coiled spring. In this, you'll see the coils moving up and down, and the wave goes this way, T-shape, transverse wave. In this, you'll see that the coils of each of the spring are moving backwards and forwards along the same line that you will see the wave travelling, a longitudinal wave. The motion of the coils is along the same line as the wave. So let's make it go. Let's make it go again. You'll see any coil there, it's moving backwards and forwards like that. But the wave moves that way. The movement of the coil is along the same line as the wave travels. Last time, watch them both carefully. Watch the difference. Now, in our next program, we'll be talking about sound waves. And sound waves are longitudinal waves. You can think about, instead of a coil of the spring, you can think of air particles moving backwards and forwards like that. But that comes in the next program. Well, now, we'll go on in a minute to look at some water waves and then to talk a little bit about things like velocity, frequency, and wavelength. So let's just look at water waves for a moment. And I'm standing here in Thimphu beside a small pond, and it's a bit of a windy day. And so it gives me an opportunity to point out, when you look at the surface of water, you may see two different types of wave. There's the first wave, which is caused by friction of the wind on the surface of the water. Now, that does actually blow the water along with it. So in some ways, it's not really a true wave. But I can make another wave, which is a true wave, by putting some energy into the middle of the pond and watching the energy move out. How do I put energy into the middle of the pond? Well, the easiest way is to throw a stone into the middle of the pond. So if I throw the stone into the middle of the pond, we can see the energy from the stone spreading out in a circle. Waves. You can see the wave motion, but remember, the water particles are not spreading out. It's just the energy, the movement of the water particles up and down that is spreading out. This is a transverse wave. Let's do it again. Watch the wave motion, a transverse wave spreading out, and you notice it goes in every direction, 360 degrees around where I throw the stone in. That's just like light from a light bulb, which comes out in every direction. Watch the ripples. So, water waves, one very good example of transverse waves. And if we watch the water waves, we can see them reflect from the side of the pond. And we can also see something else very special about waves. Now, if I have two friends here and they're holding a conversation, and I have another friend there and I'm holding a conversation, we've got sound waves going there and we've got sound waves going there. Do they crash into each other? No, they don't. The amazing thing about waves is that waves can pass through each other without being changed. Not like that with cars. You imagine two cars at a crossroads, one going that way, one going this way, and they bang into each other. That's two cars finished. Waves go through each other. Let me try and show it by throwing two stones into the pond at the same time. Watch the waves from each stone pass through each other and continue onwards. So one great characteristic of waves is that they can pass through each other and emerge on the other side unchanged. If this was not the case, we'd have quite a lot of problems with sound and light and other sorts of wave. Watch it again. Two waves created by energy from two stones, and the ripples pass through each other and come out again afterwards. Two stones. But what I do get is something, quite a complicated phenomenon with waves. The two waves actually interfere with each other when they cross. And you may later on in class 12 learn about interference between waves. But let's leave that for the moment. Suffice to know, water waves, transverse waves. The water doesn't move that way, the energy moves. The water just moves up and down like that. And a clip I'll show you from a swimming pool in Japan where the waves are going along in the water but the people just move up and down makes this very, very clear. So water waves, another very visible example of waves.